If math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. All right, testing 1 2 1 2. This is Mr. Witt with Fort Bend Tutoring, and today's tutorial will be going over midpoint and the distance formula. We have Angry Hermit in the house. We have Simone in the house. That is correct. We had some technical difficulties, but now we are live and present here with Fort Bend Tutoring. That is correct. Let's go ahead and get the chat on the screen. Before Been Tutoring, please go ahead and do that. Help us grow even more so than you've allowed us to. Let's go ahead and stretch those wings out. Go ahead and tell a friend, tell a teacher, tell a classmate about Fort Bend Tutoring. Click on that bell icon. That helps you get notified when we have live and fresh content. That's right. Live and fresh with Mr. Witt. All right, good guys, good stuff. Let me get my words together. Good stuff. And now, let's take a look at the midpoint formula I have prepared for you today. Here we go, the midpoint formula, guys. We have the midpoint is going to be equivalent to x1 plus x2 divided by 2 with y1 plus y2 divided by 2. That will be the midpoints of the point. That'll be the midpoint of the points, x1 and y1 and x2, y2. That's what we're looking at, guys. The midpoint formula. We're going to take a few problems on this topic first, and then later we'll get into some problems that deal with the distance formula. That's right. Amen, amen. Let's go ahead and get this thing underway, ladies and gentlemen, with problem number 1. And in problem number 1, it says, find the midpoint. What's going on, Saya? What's going on? You got to go to work now. Understand? Have a good day. Saya, have a good day. Saya's already giving us a nice... What you will do next is write down the formula. The midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Amen, amen. And from here, the whole point of you labeling these points is so that you can quickly identify what values go where. All right. So that means that at this point, I'll be replacing my x1 value with -3. I'll be replacing the x2 value with 1. I'll then be dividing by 2. And then I'll be plugging in my y1 value, which happens to be 4, plus my y2 value, which happens to be a negative value. So notice I'm going to include that negative sign within the parentheses and then divide by 2, closing off those parentheses finally. And then in the numerator here, I'll be able to combine. All right, the -3 plus 1 gives me -2 over 2. Then with the second fraction here, I have 4 plus -2. That gives me a +2 over 2. And so therefore the midpoint between these 2 points here, guys, is going to be -1, 1. And we will be placing our answer in a red box. That's right, and Angry Hermit has the correct answer. Epic Levi's in the house. Just join, glad I'm not missing this one. That's right, Epic Levi, you are not missing this one today, as we have just completed problem number 1, guys. Let me go ahead and get my black ink in effect, and we're going to keep this train rolling. That's right. Let's It's the midpoint formula. It has a different purpose. Absolutely correct. So as always, I suggest that you guys write down the formula every time you use a formula in mathematics. So I'm writing down my midpoint formula here, which is going to be x1 plus x2 divided by 2. I have my y1 plus y2 divided by 2. Basically, you're taking the average of your x values and then the average of the y values in order to find the midpoint between the 2 points here. I'll be then plugging in my values here. So I know that my x1 value is 4 plus my x2 value, which is -3. I'll be dividing that by 2 then. And next we'll have our y1 value, which is 0, plus my y2 value, which happens to be -5. I'll then be dividing that by 2. Absolutely. Then combining my like terms here. Let's go ahead and get things in view for you. We have 4 plus -3 gives you a +1 over 2. Then in the second fraction that we have 0 plus -5. That gives you -5 halves. And here is our answer. And Angry Hermit is showing off today. Let's go ahead and show how Angry Hermit is showing off with her. All right. Can you hear me now, guys? Can you hear me now? Sorry about that. Can you hear me now? I think I figured out what was going on. Sorry about that. You guys should be able to hear me now, right? All right. Good deal. Good deal. Talk to me. Talk to me. Talk to me. You should be able to hear me now, guys. Yeah, there we go. Sorry about that. So I was just telling Monica that she can check out our ASVAB video. And that will assist her in check out the ASVAB playlist, and that'll help you out with your GED preparations. Also, if you need any one-on-one tutorials, you can check out tutoringmath.net to set up an online tutorial, and that will assist you there. All right, guys. Technical difficulties today. Sorry about that. That was my fault about the audio, but it is fixed now. All right, so let's keep it pushing, guys. Let's keep it pushing. We have problem number 3 here. They want us to find the midpoint of the line segment with endpoints -6 2/10, 1 5/10, and 4 8/10, 5 7/10. This is what we want to check out. So we're going to start with the first point here and the second point, and we're going to start with labeling these points. So we'll have negative 6 2/10. That's what we have. 1 5/10. The other point is going to be 4 8/10, as well as the 5 7/10. I am all discombobulated today. I was not expecting the audio issues, but there we go. Thanks a lot for that playlist link there, Angry Hermit. Appreciate that. So as I stated before, we're going to start by labeling x1, y1, x2, y2, and then we'll be going ahead and writing this midpoint formula here. So the midpoint formula is going to be x1 plus x2 divided by 2. We'll then have y1 plus y2 divided by 2, and then we'll be plugging in our values and simplifying here, guys. So we'll have the negative 6 2/10 plus the 4 8/10 divided by 2. We'll have 1 5/10 plus 5 7/10 divided by 2. So here is my setup. All right. From here, we'll go ahead and simplify the numerator. We have the negative 6 2/10 plus 4 8/10. And I'm just going to pretend I don't know what that is. Or am I pretending? I don't think I'm pretending right now. I'm just pulling up blank today, guys. So we end up with negative 1 4/10 divided by 2. All right. Then as we move on, we have the 1 5/10 plus the 5 7/10. Let's just go ahead and play it on the safe side since my brain is malfunctioning today. We'll end up with 7 2/10 divided by 2. From here, continue to simplify this, guys, and we should end up with, what's going on, Obina? We should end up with negative 7/10, and the other one will be 3 6/10. So our result here is going to be negative 7/10. And what's going on, Lewis? And we have our y value as 3 6/10, and this is our answer for problem number 3. There it is. There it is. We have it, guys. Done and done. Yeah, that's what's up. That's what's going on here. Yeah, let's get everything in view here. So now that we have the audio working correctly, now that we have more people in the chat helping out, maybe we can get this underway correctly now with problem number 4, ladies and gentlemen. In number 4, it says to find the other endpoint of this line segment with midpoint 4, 6 and endpoint 7, 9. So in this case, we're not solving for the midpoint. We already have the midpoint, but we will still be able to utilize that midpoint formula in order to answer the questions that we have. All right. So let's go ahead and take a look. So when you're looking at this 4, 6 here, this is actually the midpoint's x value, the midpoint's y value here. And our other endpoint, or one of the endpoints that we're given, is 7, 9. So it doesn't matter whether you label this point as x1, y1 or x2, y2. That'll be up to you. In this case, I'll just go ahead and label it as x1, y1. All right, that's the first point, and I'll be solving for the second point. So as I look at the midpoint formula, we can break down that midpoint into its different values that we want. For instance, we can say that we have the x value of the midpoint, we have the y value of the midpoint, and that would be equivalent to our formula that we have, which is x1 plus x2 divided by 2, and we have the y1 plus y2 divided by 2, right? I hate that 2. Let's fix that 2. There we go. It's a better 2. So using this formula, and we can solve for each of the values of the midpoint separately by plugging our values. The first equation will look like this. We'll say that we have 4 equivalent to 7 plus x2 divided by 2. And then we can use this formula and solve for the x value of the second point, of that second endpoint. And then the other equation, we would say that we have our y value of the midpoint, which in this case is 9, and that'll be equivalent to our y value. Hold on. That's not right. The y value of the midpoint is 6. Let me get my lie together. You guys better watch me today, because it looks like I am being loosey-goosey as far as my brain functioning is concerned. All right, so Bina already has a result of 1, 3. Let's go ahead and see if that works. And then on my side, I'll be multiplying both sides by 2 here. So I can show that by saying I have 2 times 4, and this is going to be 2 times the quantity of 7 plus x2 divided by 2. On the right side, the 2's cancel out. I'll end up with 8 equals to 7 plus x2. So if I subtract 7 to both sides here, I'll end up with an x2 value. And I'll just throw this up here, guys. I'll end up with an x2 value of 1. Yeah. So that first endpoint ends up giving us a value of 1. Can I squeeze that in here over here? No, I'm not going to even try. It's going to be jacked up. So, yeah. So 8 minus 7 gives us 1. That you should know. There you go. So that's going to be our x2 value. And we can label that right here. That makes it a little better. And now, what's going on, John? Using a visual, I use a pegboard. It's really helpful to my students to see the pattern of what does the x value do to get to the endpoint. Thanks for that tip, John Berry. Thanks very much, sir. Appreciate that. And Simone says, what did you say about the equation when I said that looks like the slope, but you're adding instead? Oh, you couldn't hear me. Oh, yeah, I said that it's similar. And I see that because we first start out by labeling the slope. All right. Just the same way, those points as x1, y1, and x2, y2, but the formulas and their purpose is different, Simone. So that's what I was trying to tell you when my audio was jacked up. And I see right now I'll have to redo this video so that it'll be clear for everybody. All right, good deal. So that's what occurred, Simone. Thanks again, John Berry. Let's go ahead and give you some love, man. Give you a shout out over there since you're being helpful. That's right. And Obina loves explanations. Yes, she does. She loves little explanations over there. Edgar Hermit says, question, how does this apply to the real world? Like, what would you use this skill for? Well, that's a part of the problems that I'll be showing you today, Edgar Hermit, because basically this skill can just be, one of the easiest skills that it can be used for is just the distance between two places. You can look at this as finding the distance between two cities. All right, you can use this a whole lot of different ways when you need to find the length between 2 points in the real world. All right, good stuff. Well, enjoy your summer vacation, John. All right. Obina is definitely saying architecture. Absolutely. So there's a lot of literal applications for this. Computer design, there's all kinds of ways so that you'll need to know the lengths between two values or 2 points, 2 destinations. All right. So all of those are ways that you can utilize the midpoint formula to find out that middle destination point or what have you. Or let's say for the center of a circle, for instance. All right. Let's say you have 2 endpoints of a diameter. You can use the midpoint formula to find out the center of that circle. So Angry Hermit says, that's interesting. Thanks. She has our answer. Let's go ahead and solve for this y value, guys. So we end up multiplying both sides by 2. When doing so, we know that 2 times 6 is 12. Running out of room over here, guys. On the right side, those 2's will cancel out to give me 9 plus y2. Subtracting 9 to both sides of the equal sign, we end up with 3, which equals to y2. So therefore, and let's put a purple circle around this intermediate value that we'll need for our answer here, we'll end up with 3 for the y2 value. So therefore, our solution will be placed in a red box here, ladies and gentlemen. There you have it. We have our solution in a red box. Now that everybody can hear Mr. Witt clearly, and I'm not going in and out. All right, so here we go. Let's try this out, guys. In problem number 5, it says, in the figure below, find the midpoints of FB, BT, and FT. The midpoints. That's what they want. They want the midpoints of each of the segments of this triangle here. So why don't we go about finding out what the coordinates are for each of these points first? And let's go ahead and, of course, start with F, as in FBT. Let's go ahead and check that out. So this first coordinate is going to be -3, 2. So point F is -3, 2. That's where it's located on our Cartesian plane here. For point B is going to be located at 1, 5. We have a coordinate for point T at 3, -1. So if we're asked, guys, to find the midpoint, and let's go ahead and put that midpoint formula over here. Well, we'll have x1 plus x2 divided by 2. We have y1 plus y2 divided by 2. All right, it's supposed to be a 2 over there. Imagine that's a 2 over there. Do I have to fix that 2? Okay. Okay, I guess I have to fix this 2 over here because you guys are being picky today. All right, that's better. That's better. So we're going to utilize that. Lewis says college test question. There you go. You can see problems like this definitely on standardized test, of course. So here we're going to find out the midpoints of these line segments here. And we're going to start out with the midpoint of, and we'll just label it as the midpoint of segment FB here. There we go. So FB is going to be the midpoint between these 2 points here on our triangle. So if you were to go in and label this, let's say as x1, y1, and you were to label point B as x2, y2, like so, then the sum of the x values, guys, is going to be our numerator, right? So that means that when you combine -3 and 1 together, you'll get -2, right? And then when you're looking at the sum of, and that's going to be divided by 2. Let me get my lie right. And then as you add your y values together, that 2 plus 5 gives you 7. And that'll be divided by 2. So in simplifying the midpoint here for our midpoint for segment FB, you should end up with -1 and 7/2. There you go. -1 and 7/2, or as Angry Hermit wrote it, -1, 3 and 5/10. Good stuff. And Obina already has her midpoints for all 3 line segments. Very good, Obina. Very good. Going ahead and showing off today. I see you. Keep it going, Obina. Let's continue on. We're looking at the midpoint for segment BT now. All right. The process remains the same. You're going to be now looking at the fact that we can just label this, I guess, as X2. No, x1. We'll label it as x1 and y1. There we go. So if we combine the x values between the b and the t, x values here, you'll end up with 3 plus 1. That'll give you 4 divided by 2. Then combining the y values, you'll end up with 4 divided by 2. And then simplifying this, you'll end up with a midpoint for segment BT that is 2, 2. Very good, Anwar. All right. Obina, I think you did tell me that you were a boy last time. Did I call you a girl again? Yeah, you definitely told me that you were a boy last time, and I had made that thought to myself. So I apologize if I called you a girl again, because Obina, guys, is definitely a male. Okay? So I apologize for that, Obina, but you did let me know. All right. So now we're going to continue then. We're going to continue. Oh, it's Simone. I called him a girl again? All right. Well, I apologize if I did. All right. So I do know that you're a male. You did inform me last time after you let me go like for 3 or 4 streams, assuming that you were female just for fun. Obina, thanks a lot. All right. So now we're looking at segment FT here. And so for F and T, and you can, of course, change the labels on this so that one of them will be X2, Y2 for this particular formula. But as we look at this problem here, the sum of the X values is the bottom line. That's what we'll need. And that is -3 plus 3 gives us 0 divided by 2. And then combining your Y values, you'll have 2 and -1 to give you a +1 in the numerator over 2. So that means that your final midpoint for segment FT is going to be 0, 1/2, and these are the 3 midpoints for this problem. All right. Good stuff. So, Simone says that she saw the video where you had told me that you were a boy. Yes. All right. Good deal. Are y'all jumping on me? Y'all already know I'm vulnerable today after all these technical difficulties and my brain being turned off. That's not good. So here we end up with the results in a red box for this problem. So we had a diagram where we were given a triangle, and they wanted us to find the midpoints of these line segments of the triangle. So that meant that we had to go in and find our own coordinates for those 3 vertices and go ahead and find their respective midpoints for all of the line segments of the triangle. Amen, amen. And that was problem number 5, guys. All right, now, just for practical use, guys, here is a situation where we may end up using the midpoint formula. All right, Lewis says it's official now. It's called helping you remember, not jumping on me. That's what you say, Simone, but it feels a different way. But definitely help me out, guys. I need your help always. So in problem number 6, we want to find the perpendicular bisector of the line segment with endpoints 6, -3, and 0, 5. So in a situation like this, we need to first of all, realizing that the endpoints of this line segment will assist us in finding the midpoint, all right? We will then need the slope between these 2 points to find out their perpendicular slope, okay? We'll need to know the slope of the perpendicular line, and so we'll be doing quite a few steps here, and one of which is going to be, of course, using the midpoint. All right, so the first thing that we'll do, guys, is we'll find the slope between these 2 points, and just like was it Obina? No, it was Simone. So just like Simone was saying, the start of this is identical, that you'll start out by labeling your points, x1, y1, and x2, y2. But this time, we'll need to find out that slope by using the slope formula. And recall that the slope formula is y2 minus y1 divided by x2 minus x1. And this will assist us in finding out the perpendicular bisector of the line segment with these endpoints right here. So, plugging in our values, we'll have 5 minus -3 divided by 0 minus 6. In the numerator, 5 minus -3 is equivalent to 5 plus 3, right? So we'll end up with 8 over -6, which reduces to -4/3. So we begin by finding out that the slope between the given points here, our endpoints, is -4/3. However, a perpendicular line slope to this is going to be the opposite reciprocal. So that means that we need to change the sign and flip this slope that we just solved for. Because in order to find the perpendicular bisector, you need to find out what the slope of the given point is, the given points are, and then find out their opposite reciprocals. So that means that we end up with 3/4 for the slope that we'll be using. All right, can I write a better 4 here? I think I just did. There we go. So we'll hold on to this. That's right. So the perpendicular line slope to our given endpoints is going to be the opposite reciprocal. In other words, change the sign and flip it once you have that given slope. All right. So 3/4 is exactly right, Lewis. So now, guys, we need to find out the midpoint between these 2 points and have our slope be equivalent to 3/4. So using that midpoint formula, all right, and I need to get my ink on correctly. Hey, everything's just all wacky today, guys. Bear with me. We're going to be utilizing that midpoint formula, which is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. Here we go, here we go. All right, getting better. Getting better than plugging in these values here. We'll have a midpoint that's going to be the result of 6 plus 0, right, which is going to be 6, then divided by 2 gives you 3. Then as your y values are concerned, you'll have -3 plus 5, which is positive 2. 2 divided by 2 is 1. So we end up with a midpoint of 3, 1. So now what we have before us is we have a point and we have the slope. And I believe we'll go ahead and write our perpendicular bisector, guys, in point slope form. And what is point slope form? Point slope form, guys, is going to be y minus y1 equals to m times x minus x1. So using the point, which is the midpoint here, as well as our perpendicular line slope, we'll be able to write our linear equation that represents the perpendicular bisector. All right, so here we go. It'll be y minus our y1 value will come from our midpoint, which will be 1. This equals to our perpendicular line slope of 3/4 times x minus our x value from our midpoint, which is going to be 3. And so this is going to be the equation of the perpendicular line, the perpendicular bisector, all right, of the given endpoints. And this is Done and done. Simone says, this makes so much sense after seeing your parallel and perpendicular line video. Absolutely. Absolutely. So notice how we were able to combine all of that together. All of that knowledge that we learned in that video together with this, Simone, in order to make that happen. And so Romany is giving us a different form of the equation. And Romany, if you were to add 15 to both sides of your equal sign, you would actually have your equation written in standard form. All right. Good stuff. Lewis says, college test. I used the slope of two lines to see if it was 90 degrees or to make it a right triangle. That's correct. So on a standardized test, you can definitely check out to see if the slopes of the two lines would make a 90-degree angle, and they would if their slopes are opposite reciprocals of one another. And that'll give you your 90 degrees. And then verify whether or not you're dealing with that or not. That's right. And Obina says, why did I write this in slope-intercept form again? Oh, wait, it's so easy. No problem. Yeah, you can definitely write your answer in slope-intercept form. Yeah. So that's one of the things, because they didn't tell us what form they wanted the linear equation to be written in. So you definitely had some freedom in how you presented your answer. So you could have given the answer as standard form. You could have wrote it as slope-intercept form, point-slope form, as I did. So all of those were viable answers to that problem, guys. Definitely. All right, so just wanted to remind you guys that you could always set up a paid online tutorial today with Fort Bend Tutoring by checking out our website, tutormemath.net, clicking on the online tutorials link, and setting up an online tutorial with me. And hopefully that day, my brain will be on that day because I am struggling today, guys. I am struggling. But you guys are assisting me, so I appreciate you joining me today to keep me in line because I definitely need your help today. So checking out our distance formula. All right, so the distance between 2 points, this formula is as follows. We have the distance between 2 points is going to be the square root of the difference x2 minus x1 squared plus the difference y2 minus y1 squared. Yeah, that's going to be the distance between the points that are in the format x1, y1, and x2, y2, as you see before you. So this is the distance formula, guys. That's what we have. We have our distance formula here. So let's check out some radicals. Let's check that out. So here in number 1 for our distance formula, guys, we want to find the distance between the points 1, 2, and 7, negative 3. So this is what we're going to be doing. We're going to be starting out by labeling these points as x1, y1, x2, y2. So this part is definitely going to be using a different formula that will assist us in finding the distance between two given points. Angry Hermit says basically the Pythagorean theorem. Yes, the distance formula is definitely related to the Pythagorean theorem, and you can use them interchangeably, especially on the rectangular coordinate system, to solve for the distance between 2 points. Good point, Angry Hermit. Pun intended. All right, so let's take a look at this. If we start out with our formula here, that the distance is equivalent to the square root of x2 minus x1 squared, writing down our formula so that we can plug the values in. We'll have y2 minus y1 squared. So you're going to end up with the following here. So this looks like, with our x2 value being 7 minus our x1 value being 1, we'll square that result, and then we have our y2 value being negative 3 minus your y1 value, which is 2, and we'll be squaring that result as well. So we end up with Obina giving us an answer of the square root of 61. Let's see if we match Obina's result here. I know that at this point that we have within the parentheses 7 minus 1, that gives us 6 squared, plus negative 3 and negative 2 will combine to give you negative 5 squared. All right, like so. And so continuing to simplify this result, we'll have 36 plus 25, and Obina is correct with the square root of 61. All right, good stuff. And Angry Hermit looks like she is rounding that to the nearest tenths place with 7 8/10. With 7 8/10. That sounds accurate to me, Angry Hermit. All right, but you can feel free to give your exact answer as the square root of 61. So unless they tell you to simplify and round it perhaps to the nearest tenths place, it is actually better to give an exact answer in the form of the square root of 61, guys. That is definitely acceptable, as you cannot simplify this result any further. Amen, amen. And as far as simplifying square roots are concerned, Angry Hermit, if you don't mind, there is a video called Simplifying Square Roots that can assist you in breaking down results such as the one that you see here. That's right. Lewis says college will ask, sometimes the college will ask for a rounded answer. It depends on the course that you're dealing with. All right. And a lot of times they'll need an exact answer. So it all depends on the instructor and what they're trying to do with their class. So there you go. Angry Hermit says, the last time I did this, the answers were in that format. I understand, Angry Hermit. The format can be in different ways. You can see that format. All right, let us continue. Amen, amen. Here we have problem number 2, guys. Thanks a lot, Angry Hermit. Angry Hermit has the link, guys, for simplifying square roots. There it is. Angry Hermit has the link for simplifying square roots. Appreciate that. So with problem number 2, guys, we want to find the length between the points -8,2 and -4,1. So what we'll do here is we'll start out by labeling these points as x1, y1. All right. We'll definitely do that. And we have the other point as -4,1. So label that as x2, y2. And then, of course, your distance formula is going to be the distance is equivalent between those 2 points is equivalent to the difference of x2 and x1 squared plus the difference of y2 and y1 squared. So here we have our distance formula. What's going on, Jorge? What's going on, George? How's it going there? George Nathan is in the house. That's right. So why we are doing this, George, is to solve the distance between 2 points. That's what we're doing. So we did some midpoint formula problems, and now we're doing distance problems. That's what's going on with that. Obina has a result of the square root of 17. Let's see what's up with that. Square root of 17 says Lewis. Plugging in my values here, guys, we have our x2 value as -4. Minus our x1 value, which happens to be a negative value as well. So we're going to get a little loosey-goosey with the parentheses here. Plus y2, which happens to be 1, minus my y1 value, which is going to be 2. And that's going to be squared as well. And so in simplifying this, continuing on, removing the chat from the screen here so everybody can see, we'll have -4 plus 8, because these two negatives will combine and make a positive. -4 plus 8 gives you 4 squared. And then, of course, you'll have 1 minus 2, which is going to be -1 squared. All right. So that gives you a next step that looks like this. It'll be the square root of 16 plus 1 to give us a final result of the square root of 17, which once again cannot be simplified any further. So the exact answer is square root of 17. Good job, Angry Hermit. Good job, Lewis. Good job, Obina. Way to go, guys, with your results, which are the square root of 17 as far as finding the distance between the 2 points that we have here on the screen. Yeah. That's what's going on. That's what we got. That's what we have going on, guys. We're looking at problem number 3 now. We're keeping it moving. We're keeping it moving. Oh, yes, we are. They want us to find the distance between the points 4 and 7/10, 2 and 3/10, and the point 1 and 7/10, -1 and 7/10. What are you going to do with the decimals, ladies and gentlemen? I know I'm going to start by labeling this as x1, y1, labeling the second point as x2, y2. And then once I have this, what's going on, George? You said, what if you're given the midpoint value? How do we find the points? Well, you want to go ahead and once we have this uploaded, George, you can replay this because I believe we did that on problem number 3 with the midpoints. So go ahead and check out that problem once the video here, once the stream has been posted. We had a problem just like that. Simone says, how do you add the 4 and 17? Or how did you add the 4 squared when it was being added to a -1? Well, first of all, you find out the result of what 4 squared is first, Simone. So 4 squared means 4 times 4, which is 16. And then the -1 squared So this goes back to the order of operations. You need to simplify by taking care of the exponents before you try to add it. All right. And so that would have resolved your issue there. All right. So that's what was lacking when you were doing that. OK, so there you have it. There you have it. All right. Good deal. Now, let's go ahead and check out problem number 3, guys, as we're going to be using the distance formula. So we have the distance formula written as the square root of the difference of x2 minus x1 squared plus y2 minus y1 squared here, like so. We'll go ahead and plug in these values. We know that our x2 value is going to be 1 7/10 minus our 4 7/10 here. That was our x1 value, and we're going to then square that difference, plus our y2 value, which is negative 1 7/10, minus our y1 value, which happens to be 2 3/10, and that difference will be squared. All right. Good stuff, George. Glad you understand. All right. So at this point, guys, we're going to then simplify this further. And 1 7/10 minus 4 7/10 gives us negative 3, which is still being squared. When we combine the negative 1 7/10 and the negative 2 3/10, guys, you end up with negative 4, which is being squared. From here, let's go ahead and put things in view. We'll end up with negative 3 squared, which is 9, plus negative 4 squared, which happens to be 16. And then the sum of 9 and 16 is 25, so that when we take the square root of 25, the result, the distance is 5 units, guys. And we have our answer in a red box. That's right, Lewis. You'll need to simplify that further because we know that 25 is a perfect square, so the square root of 25 is 5. So we can definitely simplify that square root of 25 further and get a result of 5 on that problem there. All right. Good stuff, guys. That was a good problem with decimals, right? There you go. You know how you love decimals. See, I provided. There you go. I'm a good provider. Definitely a good provider. There we go. We had our decimal question in effect. Now, how do you like this, though? The problem that has radicals. See, just when you thought things could get better, it can. There you go. It's getting better with the radicals in the question. This is what we're dealing with, guys. Number 4, we have find the distance between the square root of 2, square root of 6, and negative 2, square root of 2, 4, square root of 6. Angry Hermit says decimals are disgusting. All right, well, let's see. Let's see what you think about the radicals of this problem here. All right. So once again, we want to start by labeling our points here. We have x1, y1. We have x2, y2. We have our distance formula here, which will be the square root of the difference of the x values. So we have that squared plus the difference of the y values will be squared. We'll have y2 minus y1 squared. There you go. Always writing down that formula as we work out these problems, so it'll be easier to identify where we should plug in our values, guys. All right, you want to help your brain out as much as possible. Feed the brain with information, guys. So that being the case, let's plug in some values, shall we? We have x2 being our negative 2 and square root of 2 here, minus our x1 value, which happens to be the square root of 2. That's going to be squared, plus our y2 value is 4 times the square root of 2 minus our y1 value is the square root of 6 here. There we go. That result will be squared. Okay. Continuing on, we have the following. We'll end up with this, guys. Let's see here. We'll have negative 3 square root of 2. That's being squared. So negative 2 square root of 2 minus the square root of 2 gives you negative 3 square root of 2, which is still being squared. Then in the second set of parentheses, you'll have 4 square root of 6 minus square root of 6 gives you 3 square root of 6. So when you're subtracting like terms, and these terms are alike because their radicals are the same, then you can subtract those by adding and subtracting their respective coefficients, the values in front of those radicals. That's what you're going to be adding and subtracting once you've identified them as like terms. Now, Let's square these values underneath the radical, guys. When you're squaring this, because this is a monomial, meaning one term inside the parentheses, everything within will be squared. For instance, we know that -3 squared, meaning -3 times -3, is 9. And then the square root of 2 squared, meaning the square root of 2 times square root of 2, is just 2. So the end result of this is going to be 9 times 2, which is 18, guys. That's what you end up with after you square -3 square root of 2 squared. Then with the second term here underneath the radical, you'll be squaring the 3 to give you 9. And then squaring that square root of 6, you'll just get 6. So 9 times 6 gives us 54. This is what we have thus far. So you'll next have the square root of 72, which can be broken down into the square root of 36 times 2, which gives you a simplified version of this answer, which is 6 times the square root of 2. And 6 times the square root of 2, guys, is the exact answer of this problem. Let's go ahead and make a better box for our answer here. There we go. You can now see it clearly that the result is 6 times the square root of 2. Amen, amen. And let me go ahead and do a little slow motion, guys, on that -3 times the square root of 2 squared, so you'll see exactly what occurred here. All right. So you could actually expand this if you wanted to. This -3 square root of 2 squared, it means -3 times the square root of 2 times -3 times the square root of 2, right? So notice that once you expand this, you can then focus clearly on the individual parts. So for instance, you can multiply the -3 times the -3. You know that's 9, right? And then the square root of 2 times the square root of 2 will give you initially the square root of 4. And the square root of 4 is 2. So that's how you end up with 18 as a result there. And you do a similar process. You do the exact same process, actually, when you're squaring the 3 times the square root of 6. Lewis says you hate decimals, and Lewis says I hate square roots. I understand, sir. We all have our likes and dislikes in life, don't we? That's what makes us unique snowflakes. We are all unique. That's right. We have our own likes and dislikes. All right, so that is going to be problem number 4, guys, on the distance formula problems here. There you go. There you go. Now check out number 5, Lewis. I think you'll appreciate this as a college test question. All right, definitely is from a standardized test question. This is a good one. All right, it says to find the length of the median from point F to BT. Find the length of the median from point F to BT. So what they're looking for, guys, we're looking to identify where the midpoint is between BT. So there's going to be a midpoint in this area here that we're going to need to solve for. And we'll need to find out the length of the median from point F to this midpoint here on BT. This is the median of the triangle. So as far as finding the median of a triangle is concerned, and we want to find the length of this median, we'll have to combine what we learned as far as finding the midpoint with the distance formula. That's exactly what we'll need to do here. So in order to find out the length of this median, this line segment from the vertex F to the midpoint of the line segment BT, will combine the two things that we learned today. You'll need to find out what the midpoint of BT is using that midpoint formula that we touched on earlier. And you're also going to need to use the distance formula or a similar process to find out the length of the end result, that median that we'll have. All right, so this is a great question here. I love this question. So let's first of all identify the coordinates of point B and point T, because we'll need to identify what that midpoint is. So the coordinates of point B, guys, is going to be -5, -4. Then the coordinate 4, all right, it's -4 there. There we go. So it's -5, -4 for point B, and then for point T, we'll end up with 2, -4. All right. So this is going to be the result that we have. This is the result we have for the coordinates for B and T. Then, moving on, let's go ahead and look at the midpoint between these 2 points. So what you'll do is, using that midpoint formula from earlier, that x1 plus x2 divided by 2, the y1 plus y2 divided by 2, let's go ahead and plug these values in. So that means that the -5 plus the 2, that's going to give us -3. And so we'll divide that by 2 to get -3/2. Then as far as your, yeah, scientists hate squares in the denominator, square roots in the denominator. That's true. We have to rationalize those. So then for the y value of our midpoint, you'll have -4 plus -4 to give you -8. And -8 divided by 2 is going to give you -4. All right. So this is what we have for our midpoint. Whatever that says, Angry Hermit, God bless you. So then, continuing on here, we're going to take this midpoint, okay, as well as the coordinate from our first point, which is going to be point F, which is at 0, 1, by the way. And we're going to find out. Oh, that's forbidden tutoring in Japanese. Awesome, Obina. That I did not know. Good stuff. Nice. Let's go ahead and put that on the screen for a second. All right. So Anger Hermit, hit me up with that, guys. All right. And so translated in Japanese is forbidden tutoring. Awesome. Thanks a lot, Anger Hermit. Appreciate that. That shout out over here. Okay, so now we'll be able to utilize the midpoint here, because this is we'll say that that's point M, which is the midpoint of BT. We're going to be utilizing this and point F in our distance formula to find out what this result is. Good stuff. So the distance formula, once again, is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and then plugging in our results here, guys, we'll have x2, and we'll say that x2 is just going to be our f value here. We'll say that we'll describe this as x2, y2, and we'll say that our midpoint, point M, is x1, y1. So we'll have x2, which is going to be 0, minus this -3/2 here. All right. And then we'll add to that our y2 value, which is 1, minus our y1 value, which is -4, and square that as well. So simplifying this is going to be a positive 1 and 5/10 squared plus 1 plus 4. 1 plus 4 is going to give us 5 squared here. All right. And so now, okay, that we have this, you'll end up with 2 and 25/100 plus 25. You'll end up with the square root of 27 and 25/100, and finding out the square root of 27 and 25/100 there. All right. I'm going to have to cheat over here with my calculator, because that is not something I know off the top of my head, guys. We'll go ahead and round this answer, guys, to the nearest. We'll round this answer to the nearest 10th on this one. How about that? We'll round our answer to the nearest 10th on that one. So let's see here. What did you guys end up with? The square root of 27 and 25/100. What you get? What you shocked about, Simone? What is shocking? I want to know. What do you say is shocking here? Simone, what's so shocking? Obina says, I learned in math club that it's recommended to keep the answer in a radical form. Yeah, that's true. However, in this particular problem, we have a decimal. You see that? You have 27 and 27/100. So you're not going to have a decimal and a radical really left like that usually. It's either going to be one or the other. So if you have a decimal underneath a square root sign, most of the time they'll want you to leave it in a decimal notation. So rounding to the nearest tenths place, guys, we're going to end up with 5 and 2/10. 5 and 2/10 is going to be the result that we'll leave it in. Now, you could have put it in radical notation. You could have done that. I mean, you could have left it as a fraction, rewritten 27 and 25/100 as a mixed number, or as an improper fraction, rather, and then left that in a radical. But then, of course, you would have a, it'd be over 4. So then you would have the square. You would have 2 in the denominator. Yeah. So there you go. No, Simone. No, my brain's not working like that today. No, I wasn't going to be able to pull out that decimal just like that, just by looking at it. And I guess you're talking about Dexter's from Dexter's laboratory. That's what you're talking about? Nah, not on that problem. No, Mr. Witt is definitely rusty today. Let's move on to problem number 6, guys. Red box in it indeed. Yeah, we definitely threw that in the red box pretty quickly to get away from that. So it's in the red box. It's safe in the red box now. Let's go ahead and move on now, guys. All right, do them both for extra credit. It says you, Lewis. Problem number 6, guys. It says if FT, segment FT, is the diameter of circle B, find the center of the circle and the length of the radius. That's what we want to do. We want to find the center of the circle and the length of the radius is what we're looking forward to doing here in this problem number 6. Okay. All right. So this problem, ladies and gentlemen, we have 2 endpoints of a diameter. Okay. We are not told where the center is. All right. But we are told that F and T lie on the diameter. So as long as we have access to the diameter, we can always find half of that, all right, or find its location at the midpoint. In other words, in order to find out the center of the circle. And so that's exactly what we'll be doing. So we need to first and foremost find out what the coordinate of F is, which is going to be currently at -1, 3. And also what the coordinate of T is. Coordinate T is going to be located at 7, -5. All right. And so utilizing these, we can go ahead and find out what the midpoint is, and that'll give us the center. All right. Angry Hermit says, yo, I got other fish to fry, so I'm afraid I'm going to have to leave early. Thanks for the stream. Hey, my pleasure, Angry Hermit. Thank you for joining us this far. I appreciate that. You take care. All right, so Bina has a midpoint of 3, -1. All right, let's go ahead and check that out. So first of all, that midpoint formula, guys, we know is going to be x1 plus x2 divided by 2. We'll have y1 plus y2 divided by 2. And plugging in our values here, our x1 value is going to be -1, all right, plus 7. That's going to be divided by 2. We have a y1 value, if we were to label this, of course, as x1, y1, x2, y2. Got caught up in telling Angry Hermit goodbye. I forgot to label. We'll have 3 plus -5 divided by 2. Simplifying this, we'll have 6 divided by 2. We'll have -2 divided by 2. And you end up with a midpoint of 3, -1. All right. So that's what we have thus far. Good stuff. So Obina is correct with his answer of 3, -1. And this is the center of the circle. So this is a valid result right here. There you go. That is a valid result. Now, the next thing that we want, and they said to find the center of the circle. That's right, Obina. Obina says, I almost gave up at the sight of the problem. That's right. Meaning that you definitely need to focus, guys, on what they're asking for. So they didn't necessarily want the midpoint between those 2 points. They wanted the center of the circle. Okay, and so we know that the center of circle B, all right, so this point would be B here, all right, and that coordinate for point B we now know is going to be at 3, -1, okay, so that's at 3, -1 here is where the center of that circle is. We know that that is one result of the answer, but the other thing that they want is the length of the radius. So there's 2 ways to go about doing this. We can just simply find out the length of F and B. We can find out the length of B and T, or we can find out the length of the diameter and then divide that by 2. So there's different approaches to solving this problem. So what I think I'll do, because I like, small numbers, is that I'm going to find out the distance between F and B. That's what I'll be doing. So I'm going to use some tiny numbers in here, hopefully here, that won't stress me out. So that means that I'm utilizing this formula again, this x2 minus x1 squared plus the y2 minus the y1 squared. All right. And I think I'm definitely going to need an additional page here. So let's go ahead and add a page to the drama. Let's go ahead and add a page here to help us out. There we go. Let's grab some room, make some room here. Let's make some room over here. So what did we say that F was, guys? F's coordinate was -1, 3. So we got -1, 3, and we have our B value. All right, so this is F, and then B is going to be at 3, -1. Okay, so sorry about that because you could not see. So now that we have our point B and our point F, we're going to use the distance formula on these 2 points to find out the length of the radius. Because remember, the radius is from a point on the circle to the center of the circle. So we know that F lies on the circle, and we just figured out that the center of the circle was at the point 3, -1. So we'll label this as x1, y1, x2, y2, and then plugging this into our distance formula that I had on the previous page there, we'll have x2, which is 3, minus x1, which is -1. We'll square that. Add to that the difference of the y values, which will be -1 minus 3, squared like so. This now gives me 3 plus 1 squared as we combine those signs. This is still -1 minus 3 squared. And then from there, ladies and gentlemen, we'll have the square root of 4 squared plus -4 squared. Well, what are you going to do with this? From here, you'll end up with 16 plus 16, right? So isn't this result going to give you the square root of 32, which then can be broken up into 16 times 2, which gives you a result of 4 times the square root of 2, guys? All right. So, Bina, I ended up with 4 times the square root of 2, being as though the square root of 16 is 4. So you should have 4 times the square root of 2. Romney exactly says, thank you. You're welcome. You're welcome. And I have my answer in a red box, just like that. Well, my pleasure, Romney. Thank you for joining us today. I appreciate you. Amen, amen. All right, so what do you think, Obina? Do you see what happened there? As we broke down the 32, we were able to identify that the largest perfect square within 32 is 16. We were then able to expand that. So expand that into the largest perfect square, because even within that 8 that you have, as you broke it down into 4 times 8, 8 has a perfect square of 4 within that. And so those 2 perfect squares, that 4 and that other 4, that gives you 16 times 2, and then you can simplify it from there to give you a final answer of 4 times the square root of 2. Or better yet, continue breaking down that 4 that you had there. All right. So, yeah, so that gives us a radius, guys, of 4 times the square root of 2. So as Angry Hermit was asking earlier, what are different ways in real life that we can utilize the things that we learned? We'll take out this problem that we just did. We were given a circle, all right, and all we had was the ends of a diameter. And with that, what's going on, Empress Hodge? And we definitely want to red box that exactly. So we were able to utilize this, and you can apply this in many different situations. Let's say that you were applying this to a circular garden or something like that, where you needed to know where the center of that circular garden was exactly. You could find out that longest chord, okay, that longest distance between the circle, which would be your carpentry, exactly, Obina. You could go ahead and find that out and then go from there. So you could use it in landscaping, you can use it in carpentry, you can use it in architecture. There's a lot of different applications that you can use that in. All right. Costume design. There's a lot of reasons why, a lot of ways that you can implement this in real life to assist you. All right, so there's many different projects that you could go ahead and do to figure that out. Lewis says, I would use a ruler. Yeah, well, using a ruler may be helpful, but being as though that ruler is just as good as your eyesight is and your own manual calculations, you may want to definitely have another way to calculate that value that may be a little bit more accurate. It may be more accurate for you to identify locations on the circle and then utilize those points per se to find out the exact location of the center using the algebraic process that we have here. All right. But yeah, different ways to solve a problem. Definitely. But isn't it great to have multiple ways to solve that problem at your disposal? Doesn't that give you more power at your disposal there? More different ways to implement the result that you're looking for. That's what math provides for you guys, different ways to solve a problem, guys. That's what we're here to do. So that was problem number 6, guys. And I just wanted to remind you guys to subscribe to Fort Bend Tutoring. Go ahead and click on that subscribe button there, please, if you haven't already subscribed to Fort Bend Tutoring, as well as click on the bell icon as that notifies you when we are live with new and fresh content. We are done, guys, for today. We covered the midpoint formula and the distance formula, and we did several problems where we were able to combine those two things into one problem, guys, and you guys were a great help to me as I sucked today. My brain really wasn't on today, but you guys helped out a lot. I really appreciate you. So we had Lewis in the house as a moderator. We had Obina. We had Angry Hermit in here as a moderator. We appreciate that. Romney was in the house. George was in the house. Appreciate you chiming in today. We also had, let's see here. We had Simone in the house, of course. Obina, if I haven't said Obina already, was in the house today. And we had John Berry stopping by. I really appreciate you guys joining me today. And as always, please rate, comment, and subscribe. And have a great day, guys. Have a great day. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.